Hey everybody, this is Larry. This is week one of the weekly premium challenge. Hit the like button and subscribe button, join me in Discord. Let me know what you think about today's problem. Apparently, this is a variation on the daily problem. Maybe. I haven't solved it yet, it seems like. So we have an interesting day today. 29, 27, distribute candies among children 3. You're given 2 integers and a limit. Return the total number way to distribute n candies among 3 children so that, okay. And of course, I imagine the thing that we just did for the daily problem, well, we cannot do anymore. So then now we have to figure out a little bit more. And maybe that's just going to be math and formula. For science, I am going to open that up. And then kind of, maybe I could look, I mean, it's progress, so we'll see. This is what I have for the daily problem. So if you watch the daily problem, you'll see how I came up with this. If you prefer to Google it, it's 2929 distribute candies among children too. So that we check that video. I literally just did it, so I'm not going to explain it again. But now, let's just say we did that, and now this is going to be too slow for this, right? So now we have to figure out how to do this math. First, I want to reduce this thing a little bit, right? Because this is just a little bit like hard to optimize, even if we can optimize. I know that, so this part, let's actually rewrite this. So we have this here, which is, okay. So then that means that's just 2 times limit, right? Because we take out the limit, minus candies left plus 1, right? So that's what we have for this one. Right? And if limit is greater than candies left, then what happens? Well, this is too big, right? How did I do it last time? This is on the thing. Oh, I just do an if statement. Okay. Yeah, okay. So I want to roll this in somewhere. That's what I want to do. So if limit is greater than or equal to limit candies left, then we have this thing, right? So this is also saying maybe if limit is less than candies left, then we do this. Right? Man, my thinking is not great today. And then now, I mean, and also, good. Why would ni be less than 0? Well, okay. Right? Okay. I guess that's that, right? Maybe? No? Okay, well. No, this is min, not max, but okay, fine. I mean, I don't know. Okay, all right. Maybe we don't worry about optimizing this. Sorry, I'm not talking about. I'm just trying to optimize this formula, and I think I don't really understand it. So maybe we'll just say, it's a little bit different. I mean, maybe we could come up with it, maybe not, but we have to figure out a smart way anyway to get it to n is 10 to the 8th, right? Is there a combinatorial way about it? Honestly, I don't know. So I think maybe it's for stuff like this. It's okay to just print out like small numbers to kind of see if you could scope a pattern or so. And it would be better to scope a pattern if it's right. Did I misread this one? Let me look. Just want to double check that I'm writing the same problem. But why is this wrong then? I just did this today. Maybe I changed something. All right, let's go back to here. All right, so that's right. But then why is this times 2 minus Candies left? Right? Why is this not right? Isn't that what I just did? I don't know what I did then. Maybe I did something weird and it was wrong. Okay. So we have this. Right? Okay. I think one thing that, like I said, I want to do is just maybe play with small numbers to see if there's a pattern that I can recognize or just spot out. So maybe we would write like I don't know, 10, and then the limit of 3 is not going to be enough, so 4, something like that, right? So we can do I limit total. Oops. Okay, that's not. So you can see that this is 1, 2, 3, 4, 5, 6, right? I don't know if that's helpful. And then you have this like 1, 2, 3 pattern. This is 3, 4, 5, 6, 7, right? So definitely there's already a pattern, and that kind of makes sense, right? And this goes down. You can see the other way, right? Because it goes 6, 7. I'm saying aloud the deltas, right? So this is 6, 7, 8, 7, 6, 5, 4, right? So that means that the number. I mean, I think I have an idea. I don't know what it is, but it's just that you have some like for 10, 4. So for what's it? N is equal to 10, limit is equal to 4. You have 0 plus 1 plus 2 plus 3 is the answer, right? And then n10 limit is equal to 5. Then you have 1 plus 2 plus 3 plus 4 plus 5 plus 6, right? Why that is, we would have to kind of double check it, right? And then yeah, limit 6, right? We have 3 plus 4 plus 5 plus 6 plus 7 plus 6 plus 5, right? Definitely made more awkward, but you know. And then n plus 10, or n is equal to 10, 7, right? That's going to be, yeah. 5 plus 6 plus 7 plus 8 plus 7. There's a plus 8, right? Yeah. Plus 6 plus 5 plus 4, right? And then 10, 8. Is going to be, 7 plus 8 plus 9 plus 8 plus 9. I don't know, there's an extra space. Plus 10? No, what am I doing? Plus 8 plus 7 plus 6 plus 5 plus 4 plus. But that's it, right? Oh, actually, there's a few more. That's why I was confused. Plus 3, right? So you have something like that, and you clearly see the pattern, right? And then the question is, how do we derive this pattern? Okay, so at least we're able to kind of get something together, right? So what is the peak of this? Unclear. I'm gonna take a candy. I have like allergies, and I'm just taking candy so that I could I want to say the peak is limit plus 1, but clearly it's not, right? Because here it doesn't. Because limit, then the peak is 6. But it's because we get chopped off on the left side and the right side, right? So if we're able to figure out why do we cut off, you know, the 4, 3, 2, 1, and then the 2, 1, whatever thing, right? Because here the limit, I mean the peak is going to be the limit plus 1, which kind of makes sense, except for at 4. But that may be because you know, you have this limit times 2 type property where, you know, as long as limit times 2 is yeah, right. So maybe we can even do formula based on that, though I don't know, right? Because I mean, and you could do even n is 10, limit 3 is just 0, right? And also beyond that. I guess for completion we could do 10, 9 for science, and 10, 10. I guess that's actually for completion, right? So you have 9 plus 10 plus 9, so that kind of fits our theory. And it goes all the way to plus 2. Right? And n is 0 to 10, limit 10. I think this one we know the answer, right? It's just 11 all the way dot plus 1. That one I'm lazy to write out. So okay, so there are a couple of things, right? I mean, on the right side, it seems like, you know, given a sequence of 0 plus 1 plus 2 plus 3 plus dot 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 all the way plus some peak x plus dot 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 plus 3 plus 2 plus 1 plus 0 maybe, right? Seems like n minus 1 is the last number, right? And limit is 10, so I mean, yeah. Yeah, okay. So limit is 0 to 10. That makes sense because, yeah, of what we do, right? Because it's going to be, yeah, 10 candy, 10 candy left, so 11 choice plus n. So this one makes sense. So any limit that's greater than n. So we could be, let's just start with that, right? So if limit is greater than or equal to n, then we have this 1 to limit 1. So sum from 1 to n plus 1, which is just going to be, what is it, like n plus 1 times n plus 2 over 2, right? Right? And that's just like a standard, you know, that's from this to this. Hope that's right. Maybe I'm off by 1, then it's embarrassing, but yeah. Otherwise, then now on the right side, the limit determines the last piece, right? So it seems like, and this is pure guessing, if you're curious what I'm doing now, I'm pure guessing, trying to figure out, is that, okay, if it's limit 9, then n minus limit is the stuff there's no like a plus 1 that we remove because that's where the limit is. Okay, so this one has 10 numbers. Is that right then? How can 10 numbers have 1 to 11? No, it has 11 numbers because it also has to include 0, right? And 0 here does not exist because if you have 0, 0 exists. 0, then if it's 0, then you have 9 because Yeah. And then if you have 1, then you have 10. Oh yeah, because then, okay, yeah. So this has 10 numbers. So the number of numbers in a sequence is going to be limit plus 1. Is that right? No, this is just limit, but maybe this is maybe a weird case, so we'll figure it out. For limit times 2 is greater than n, which is for this cases and not these cases. We'll try to figure it out, because all these has n plus 1 number of things, and that makes sense because for whatever n number is, the rest has I don't know. Yeah, because there's n ways for the second, well, there's n ways for the first number, so that's why limit yeah. Okay, that makes sense. Because the first number, the I term, is going to be going from 0 to limit. So there's 7 possibilities, and then for limit is equal to 6, there's 7 possibilities, and therefore 7 terms. Here, there's only 4, but that's because technically one of them is a 0, because if you have 4, if you have 0, then it's just not possible, so you have 0. And maybe I abbreviated this wrong, actually. I think now that I think about it, I think I saw it, but I just kind of wrote it real quickly, which is that actually 0 appear 2 times, right? So 0 and then 0 again. So technically, actually, this is still accurate. It's just that I was imprecise because okay. So that means that this thing has, I mean, I don't know if it's helpful, but yeah, right? Okay. And the peak of this is going to have limit plus 1 term. We have but is that like, I don't know. And then we have to figure out like these terms. How do you do that? I think this just goes to the limit. Like if, okay, so if my theory is right, then, oh no, because it will just be 0. So it's not that helpful. But if my theory is right, so you have like n is equal to 20, limit is equal to 8, then it should be just equal to 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, right? And that is equal to 28 or something, right? So let's try that theory, right? 28, 15, so that's definitely not right. So for 8, it goes to 1 plus, so 0 plus 0 plus 0, there's a lot plus zeros, and plus 2 plus 3 plus 4 plus 5, right? I see, because the number of zeros matter. And how do I calculate the number of prefix zeros? Well, 8 plus 8 is equal to 16, so maybe there should be 4 zeros, because you need to go up to 16 for it to be solved. Yeah, right? So then now it's 1 plus 2 plus 3 plus 4. 4 plus 5 is equal to 15. Okay, maybe that's fair. And here, yeah, okay. Okay, I think I have some ideas, but honestly I have to put it together, right? So yeah, otherwise then here, if, okay, if limit times 2 is still less than n, then we have some, or even equal to, I say, then now we have some zeros to throw out in the beginning, like, so we have impossible things. So I just got zeros is equal to n minus limit times 2. And then now it just goes, we want limit plus 1 terms total. So then it's going to be limit plus 1 minus the used ones. And then that is the highest peak. And then now we can return peak plus peak times peak plus 1 over 2, right? And then now we can roll it again. I think, because I think 28 kicks that off, right? And we could, just to confirm, print boo, right? Almost clicked on submit. Yeah, boo. And we can do a couple more cases, especially a big one, like this, and then we want something that's, I don't know, I guess this is less than, that's going to be less than, yeah. So, okay, so, oh, because it's less than n times 3. Okay, so actually we have to do a little bit better. I hate this new UI. So this is going to be, oh no, it's still less than limit times 3. So we need something that's, yeah, okay, so something like that. Okay. So we're happy with this. I'm just going to plug in random number as long as it's bigger than, it's less than half and bigger than whatever. It'll be on this boo case and we have the right answer, right? Okay, so we can kind of figure that out. Ooh, what did I do? Oh, I think I pressed back by accident. Okay, is this good? I mean, oh, we didn't submit it, so that would have been bad if I just lost it. I don't know what happened though, but I'm gonna put this in paste by or copy by accident, just in case. All right, so then now we have the case of, what case do we handle? Limit is too small, fine. Limit is greater than n, fine. If greater than 2 is less than equal to n, okay. So that means that we have to figure out is limit times 2 is greater than n, and n is less than or greater than limit, something like that, right? Because that's this one, right? Maybe I could write this a little bit better or just different for the consistency, right? So something like this, right? Because we handle, yeah, let me put n on the same side. Yeah, because we handle to the stuff. This handles everything to the right. This handles everything to the left. So we have to handle this case. In this case, we have an idea, right? We have this. We just have to kind of formalize a little bit more. So, okay. In terms of number of zeros, as we said, we want to hit the number of zeros is going to be 5. So actually, I mean, even if it's exactly 2, I think this holds, right? Because there's 0 zeros, and then it just goes up to. Yeah, if this is exactly, if n is exactly limit times 2, then this is 0, and then this should come out, right? Because we have n plus 1 terms, right? Okay, so then now you have something like this. How many zeros would there be? Just eating candy like crazy. Okay, I mean, this is an awkward formula. I kind of see it because we already talked about this, right? Which is that n minus 1 is going to be add zeros on the other side. Yeah, right? Because this implies that there are 5 zeros, right? 4 zeros, sorry. 10 minus 6. I don't know. This seems like it's too guessy. But it looks like it's right, which is that, okay, so then now the idea is that, and I'm just looking to n equals 6, right? That means that we have 4 trailing zeros. I don't know, this is all pure pattern guessing, right? Meaning that 4, 3, 2, 1, right? And then we replaced it from the peak to the right? So then it's just these 4 numbers move to the right. Because basically we have 6, or maybe another way to think about it is that we have 7 terms, right? So it looks something like this. But then because of 10 minus 4, or 10 minus 6, which is 4, we removed the first 4, and then now we added to 6 plus 5 plus 4 plus 3, right? Is that nuts? Probably. But let's YOLO it, right? So we have, I don't know, let's just go it. Right is equal to n minus limit, right? So that means that if we want to say the math from 1 to limit plus 1, kind of like this. Where is it? This? No. Kind of like this, right? So, okay, let's just write peak is equal to limit plus 1, right? And then the right is going to have n minus limit, right? So that means that to get the summation of just this part, it is just going to be peak times peak plus 1 over 2 minus right times right times right plus 1 divided by 2, right? So that would be this part. And then now we're trying to get 4 numbers to the left of that, which is just going to be, that means that with the 4 numbers to it, to the peak, that means that because limit or to on the left side, it should go, that means it's going to be, so now we're trying to say, what is this part, right? Well, the number of zeros to the left, the number of things that we remove is 1 plus 2. And so that is going to be, yeah, so n minus, okay, so peak is equal to 7, right? We want to do 4 more numbers from the I don't know, the transfer thing for the terms. And then so that means that it's going to be n minus limit terms after the peak. So that's going to be peak minus 1 minus n minus limit, right? And so this number, let's just call it left, is equal to this number. And then we just get the summation of that, whatever, sum this. And then we subtract out the things, because then now peak minus n minus limit minus 1. Oh, I guess that's the number of terms, right? So this is 4. Wait, is it? Oh yeah, I think I messed up here. Left is equal to the number of digits here, which is 4, right? In this case. Well, I thought I want 6, but no. Then that means just that, yeah, we have limit minus 1 times limit divided by 2 for the sum, right? So that's the sum from 1 to 6. And then to get the number 2, there's just limit minus 1 minus left to get the subtract part. And then, yeah, right? So something like that, if you're following. Okay, so this is right sum, say. Right, and then on the left side, we have left terms is equal to peak minus 1 minus n minus limit, right? And then left sum is equal to peak minus 1 times peak divided by 2, right? And then the left subtract term is equal to n, no, not n, limit minus 1 minus left term, and then it's, yeah, and then that's going to be your big number. So we have this, right? And then left sum minus this is going to be a left total. Left sum is a terrible word because we used to right sum the different way. And then anyway, and then now we just do left total plus right sum, right? And maybe that's good. I mean, it looks okay for here, but we could, at the very least, we can go back to doing 10-4, 10-5, 10-6, 10-7, 10-8, 10-9, 10-10, and that should test the entire range. Oh no, did I miss something? I mean, clearly, I got all these wrong, so that's good, I suppose. And this is 10-10 is a different thing anyway. Off by a large even. Why is that? Do I not have my print statement? Oh no, because my print statement's there. Am I off by 1 or something? Or all right, then let's just print out print left total, right sum, right? Yeah, because then now we can audit, right? 10-6, we have a 10-6 somewhere. 10-6 is this one. Our left, did I mess this up? Maybe I confused myself. Because this is the thing, right? Okay. So then the right sum should be 7 plus 6 plus 5 should be 22. So that's not right. It's not, I mean, I probably just did, oh no, it's 18. I just did the math wrong. 11 plus 7 is 18. And, oh no, that's right. That's 18, whoops. And then you have 6 plus 5 is 11. So this is also 18 on the left side. And there we are wrong. Right? I mean, that's okay. I think I just got maybe off by 1 on some of the maths. Right? So the left side is wrong. Let's break it down a little bit. So this should be the sum all the way to 6. So left sum should be 1 plus 2. So 6 times 7 is 21. Okay. So that's 18. Did I do the math wrong? Left sum, left sub, left total. Oh, left sub is 3, but that is wrong. Right? That's I interpreted wrong. I thought it was 1 plus 3, but no, left sub is just right. So limit is 6. So 6 minus 1 minus left. What is left? Left. Left terms. How many terms do we have? All right, let's take a look. Two. That's not right. N minus limit. Okay, so for 6, the number of terms should be 4. So n minus limit is 4. And that's it, right? Why do I have so many funky things? Okay, still not right. We have 4 terms. The sum goes to 21. Left terms is 4. Left sub is 1. So this is wrong. Oh, because I meant this is peak minus 1. I think that's why. And peak minus 1 is limits. Okay, so now we have all these things right, except for 8 for some reason. I don't know. Oh, okay. I guess that was just an empty thing. I don't know why they show it though. Okay, so just to give it a little bit more confidence, because right now, not confident at all. But let's try, like, you know, another series of numbers. And if this is good, then I'm confident about it. And it looks good, so I'm confident about it. You may ask how I come up with it. Well, hopefully now you know. This is there's probably a more mathematical way to think about it, but yeah, not a bad way to get an 1888-day streak, is there, right? I mean, of course, this is constant time. We just did a lot of if statements, but as you saw, I just kind of ran through the patterns and kind of just see how it shapes out, right? So yeah, I mean sometimes you just gotta grind. This is a hard problem, right? So it is what it is. That's all I have for this one. Let me know what you think. Thanks for watching. Yeah, stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.